Hello everyone. Let's start with an uncomfortable truth. Most of the Azure AI demos works perfectly, but most of the Azure Enterprise AI project doesn't make it in production. The question is why? The gap between proof of concept and actual project on production isn't about model intelligence. It is about the architecture. Myself, Bibin Prathap, I am a Microsoft MVP and I am a EEE senior member. So today we are going to build a medical AI agent for reference. It will use Azure Function app plus Microsoft Foundry and Azure OpenAI. So why most of the demos getting shelved? These demos silently skipping the items which is listed on the right, like observability and how verifiable answers, hallucination control, and role-based access control, etc. By attending this session, you will be leave knowing how to design an end-to-end pipeline that is ready for production, and how to build a failure resilient AI agent pipeline. What are the available instrument for observability, and how to apply data residency and compliance control. So we are going to build a medical AI agent. This AI agent should have knowledge about the note from doctor about the patient's condition. So every day patient a doctor is giving consultation to the patient and writing some note about the patient condition. So these notes are our input to our AI agent, and later during the next consultation, doctor can chat with this AI agent and plan about this patient's medications and the future treatment. So this AI agent has four main component. So it is basically using a remote MCP server which is hosted on Azure function app. So this Azure AI Foundry will act as a orchestrator and which will invoke this Azure function app MCP tools based on the instruction and the prompt. So this MCP tool has four tools. The first one is for injecting the note from doctor about the patient condition. So here let me go to a demo UI which is showing the available MCP tool. The first tool here a doctor can insert detail about a patient for data privacy purpose. Doctor will use the patient the number instead of name. So here he is writing the condition like patient 447 has stage 3 chronic kidney disease condition and so on. So And when we insert this information, based on this information, we need to build a knowledge graph. For this purpose, we are using on Azure Function as well as VeritasGraph MCP Python library. This VeritasGraph MCP is for converting the document text into knowledge graph, which is an open source project created by me. Basically, it is for converting the text into knowledge graph. So, for example, this text will once you ingest using this first MCP tool, it will create a knowledge graph similar to this. This first MCP tool is using Azure OpenAI to extract entities and relationship from the text. So when a doctor keep on adding more note about different patient, that will be each node will be mapped to a particular document, and it will be related to the different conditions like patient 4471 is related to stage 3 chronic kidney diseases and bleeding risks, etc. So uh, let's dig into Microsoft Foundry. So when a clinician ask any question like this, why should the warfarin dose be reduced for patient 4471, based on the prompt and the instruction, this Microsoft Foundry agent will act as an orchestrator and call the tools connected to this agent. So this is basically a Azure function app. So once you build and test this Azure function app on local, you can publish this to Microsoft Azure using function app, and you will get a remote server URL. So this URL you can configure in the Foundry by clicking on add tool and go to the custom MCP tool, and from here you can mention the URL which we got from Azure function app, and and let me go to the already configured tool. So here you can see the tool section, click on view, and here you can see I already configured the URL which I got it from function app. And when you publish the function app, you can get the authentication key. That key you need to use it here. That is for allowing this Microsoft Foundry agent to call the function app remote MCP. So this function app remote MCP has four main tool. First one is for injecting the document, and the second one is for querying this knowledge graph. So when you ask any question like this one, let me reload, and so it will it is calling this MCP tool automatically based on the prompt and the instruction, and this MCP tool will actually MCP tool will actually will choose a node which is close to this prompt, and then create a subgraph which is based on the selected node and its nearest neighbor. So it will traverse to next k level for or three more level and create a subgraph, and based on the subgraph it will give an answer like this one. And since each node is in this knowledge graph is connected to a source document like this one, it will show the source document citation as well as the reasoning path. This reasoning path it got from this knowledge graph, like this patient 4471 is related to this condition, and because of his condition, doctor reduced the dose of this particular medicine. So the in short, whatever question is asking to this AI agent is verifiable and auditable. Most of the business user may always question the answer from the AI agent. So this reasoning path explaining why AI agent is returning this answer. This is a big selling point, especially in the regulated industry like medical. And the fourth important feature is the data is governed, and we can give access control using a semantic layer, as well as we can we can have a guardrail to protect questions about personal detail. For example, in this AI agent, we already talk about instruction and a tool. The next component in this AI agent is guardrail. Guardrail is basically allowing to configure custom rule such as PII rules, and here we can mention what are the things we need to protect from this agent is exposing to the clinician. So this guardrail will protect this personal information, and if the clinician is going to dig detail about the name of the patient or phone number of the patient, the guardrail will prevent this, and it will show like it is blocked because it is against the safety and security control. So this AI agent is governed, and the function app which is using here is pinned to a location. So this is very important when it comes to data residency. Every country has their own rule related to data residency. The functions or the data which is using should reside on the same country. So the next thing I want to discuss is we already discussed about how VeritasGraph MCP is helping to convert this text documents into knowledge graph. So this is the reference architecture of this medical AI agent. The client is Azure AI, Azure Foundry agent, or we can create a test UI for testing this. And we have a different component in the Foundry level, like we have a guardrail and memory. Memory is for maintaining the context. So if you ask this question, and if you start asking a follow-up question, the memory will help you to maintain the context and answer the follow-up question. So for creating memory, you can either select an existing memory or creating a new memory store by clicking create new and selecting the model and the embedding model. So here when I ask this question, it choose the first MCP tool and triggering an HTTP code to this function app, this function. And once it go to the response from this MCP tool, it will build the summary based on the subgraph. So here we are using Android ID, the function key for allowing the Foundry agent to call the function app. So using this function key, this Foundry agent can call the function app, and function app has the four function as we already discussed, and Foundry will choose one of this available tool, and then we will build a sub graph. This each will choose a closest node and traverse through the nearest neighbor for k level, and then build a subgraph, and from the subgraph it will get the source document as well as the reasoning path, and whatever graph knowledge graph already built, we need to save it in a separate Azure file storage for durability. So we cannot keep the knowledge graph in the memory of the Azure function because since it is a flex consumption, during scaling or when the system get restarted, the in memory will get lost. So we should save the already built knowledge graph in a separate storage location. So when it restart, it will maintain the existing knowledge graph. So these are the main component using in this in this medical AI agent. First one is Azure AI agent, which is orchestrated tool to call the necessary MCP tool, which is deployed on this Azure function app. So there is four stages for this a medical AI agent. First stage is ingestion. In this stage, we are injecting the doctor's note and creating a knowledge graph, extracting the entities and relation and creating the knowledge graph. And when clinician prompting give a prompt to this AI agent, from the knowledge graph it will retrieve the relevant entity and traverse through the nearest neighbors for max depth, and from this and will build a subgraph, and from the subgraph it will create the answer. So the answers will be having a citation to the source document, and it will have a reasoning path. So this answer will be auditable and explainable for business users. And in this same AI agent, we can implement row level security using semantic layers such as Power BI, Dataverse, or Dynamic 360. So when a user, so for this we need to authenticate the user using auth2 authentication, and we need to generate the token and use that token for this AI agent pipeline. So this token will hold the user's privileges to view patient's data. Some doctors may have access to the patient from all the department, but some doctors may have only information about the patient from his only from his department. So this role security is defined on the semantic layer. So this we need to create an MCP to this semantic layer APIs, and then configure this MCP in this tools layer, same as we configured this VeritasGraph MCP. And when user ask show me the patient detail from all department, if he has the necessary privilege, then only he will get the list of patients from all department. Then that list of patient will come to the second MCP tool for reasoning, and will give the answer. So this semantic layer will act as a source of truth of who can see what. And this VeritasGraph MCP, knowledge graph MCP, will act as what is truth and where it come from, the source of the truth. So the next thing we want to learn is how to build a resilient pipeline. For building a resilient failure resilient pipeline, there is six main component. First is this hallucination containment. So for every answer, there should be a retrieved subgraph from the knowledge graph. If there is no subgraph, it should know the answer should be empty. So it will not be, the AI agent cannot hallucinate. If he has the knowledge, then only he can answer the questions from the user. And we should have a retry logic. For example, we talk about this semantic layer role based access retrieval. In case of Power BI natural language to DAX agent based on the user token. We need to first discover the available table schema like a table name and the column name, and once you get the table schema, you need to generate the DAX according to the natural language query. So for example, if the natural language query is show me the total sales by customer, then it should generate a DAX based on the available tables and columns, and execute it, and get the answer, get the total sales count. But during the DAX generation, it may fail during the execution due to syntax error or something. So that time there should be a self correction logic which will allow to allow this AI agent to generate a different DAX which is fixing the exception thrown the exception happened on the first try. So this self correction loop will try to generate again the better DAX, and will try to get the answer, and once this execution is successful, it will generate the summary. So why this self correction loop is for making this AI agent pipeline resilient to failure. So there should be a retry and model fallback logic and content filtering logic using guardrail for preventing oversupplying the personal data or uh, unauthorized data, and the boundary using role level access control. And yeah, these are the six pillars which is necessary for building a failure resilient pipeline. And for observability, there are six components are available on Azure Foundry as well as Azure Function app. Azure Function app has application insight session which will show the tools called by Foundry agent, and with the failure rate as well as the success rate. So this observability is important to understand about the latency and exceptions happened during the tool call. And this Foundry agent has a tracing session. In the tracing session, you will be able to see uh, detail about the tools it use from the user prompt. So based on this user prompt and the instruction, these are the MCP tools used. And the fourth thing for observability and explainability is this evaluation session. In this evaluation session, we can measure the groundedness and relevance and safety of answers. And the fourth thing is explainability. The answers of this AI agent should be explainable from the reasoning path and citations, which we already discussed here. So this answers is explainable from the citation and reasoning path. And for cost and usage, we can set alert on the spend and the limit. So regarding data residency and compliance with regional law, especially for Middle East enterprise reality, the region pin is the most important feature for a production grade enterprise solution. So for function app as well as storage and Azure OpenAI, there is option to mention the pin this to a region, so that we can set it here. And using guardrail, we can set the PAI and PHI rules. And for data governance, we can control the access layer using semantic layer row level security. So we can give least privilege to this AI agent according to the role of the user. So when a client asks a question like your AI agent is production ready, these are the 9 check items checklist. You need to make sure it is implemented in your AI agent, and you need to use this checklist to explain to this client how your system is ready for production. So the summary of this session is the gap between proof of concept and the production AI agent isn't about model intelligence, it's about the architecture. So we need to close it deliberately. We cannot depend upon luck for always when the AI agent is answering a business question. Our pipeline should be strong enough to handle any type of complex question by making it grounded. So the answer should be auditable, and it should be cited to the source document. And we need to externalize the state of the knowledge graph we already built for this AI agent, so it will maintain the state even after the Azure function app restart or scale it up according to the concurrent users. And we need to secure it, we need to make it observable, so we can debug and understand what is happening on the production. And we need to make it resilient, so there should be some retry logic and fallback logic. And we need to make it keep it compliance against regional data residency law. Yeah, thank you. Thank you for listening to this section. In case you have any doubt on anything, you can connect it to me on LinkedIn. And let's build Azure AI apps that actually work very well on production. Thank you.